Welcome to clickmyproject.com.
Let us discuss about the joint relay antenna selection and pre-coding design for two-way MIMO amplifier and forward relaying systems. Now let us discuss about the abstract of the product. So in this proposed work, an unified framework of relay and antenna subset selection and transceiver design is a proposed for dual hop and two-way amplifier and forward. So that is a AF and multi-input and multi-output. So that is a MIMO relaying systems with correlated fading channels by making the use of singular value decomposition. So that is a SPD technique. The joint design of two transceivers, so two source transceivers and multi-relay present precoders is developed based on the minimum mean square error. So that is a MMSC criteria. So this MMSC criteria based on the optimization leads to a highly nonlinear objective functions of sources and relaying precoders. So under a power constraint, so is that an iterative search algorithm is applied to explore the optimal power allocation. So the simulation results shows that the SPD based joint design of relay and source precoders, so in conjunction with the SPD based relay and antenna selection scheme, is capable of achieving superior performance. So in terms of PER, with an iterative antenna demand on relay and associated antenna pass. So an iterative search algorithm is applied to explore the optimal power allocation scheme to achieving the superior performance. So in terms of the bit error rate. Let us discuss about the flow diagram of the product. So in this flow diagram, the system model and two N antenna source nodes. So the system model is connected between the two N antenna source nodes and the K hop duplex and this R antenna. So in between the two K antenna source nodes, the hop duplex R antenna is presented. So in this system model, it's subdivided into two algorithms. One is a SVD based relay antenna subset selection, and another one is a pre-coding design. So in the SVD based relay antenna subset selection is a single value decomposition. So that is subdivided into two parts. That is a first stage and the second stage. So in this first stage, the I relays are selected from the K intermediate relays. So in the second stage, selection of L antennas located on activated I relays. So that is the second stage. So the pre-coding design, that is also subdivided into the two parts. So first one is updated source power allocation and second one is updated relay and power allocation. So the updated source and power allocation we calculate the power, and the updated relay and power selection we calculate the relay to the source and relay. Finally we calculate the superior bit error rate performance. So the bit error rate is achieving the superior value to finally performance analysis will be calculated. So all the graphs will be presented under BER versus SNR. So BER is a bit error rate and SNR is a signal to noise ratio. Finally calculate the performance of the BER. So these are the overall flow diagram of the process. Yeah, let us discuss about the running procedure for the product. So click the main file, so and then run. So there are outputs are displayed. So these are all the outputs related to our flow diagram. So the performance of the joint relay and antenna subset selection and pre-coding design is evaluated for a dual hop two-way MIMO, that is a multiple input and multiple output. So AF means amplify and forward multi-relay systems in the presence of correlation between antennas over correlated fading. So the value of the bit error rate, that is equal to. So this is the first figure. This first figure, there is a BER comparison of a class of pre-coding design techniques. So that is a BER is a bit error rate. So in the x-axis that is a SNR of dB, and the y-axis that is a BER. So already I told that we achieve the superior bit error rate of the system. So comparing to the all the pre-coding design techniques. So there is a 3 pre-coding. So these are the comparing to all the pre-coding techniques, the average bit error rate performance using the 4 array QAMs conducted. So the notation of N or KIL is used to demonstrate that a subset of L antennas distributed under I activated relays are selected from a MIMO, that is a AFK relay system. So the AF means amplify and forward, will consist of two N antenna source, that is a bit error comparison of a class, pre-coding design and techniques of the antenna. So related to the BER, so that is a bit error rate up to 10 power minus 1 to 10 power minus 7, and the SNR is a 0 to 10. So this is the process of the comparison of all class pre-coding design techniques. And then so the nodes and K intermediate R antenna relays are frequently used to exponential correlation model is adapted for both transmit side and the receive side spatial correlation matrix and all the channel lengths, specifically the ith and jth of the transmit and receive correlation matrix. So the each node is reface computed between the antenna and each node of the process. So in this figure, the BER comparison of variety of relay and antenna selection and pre-coding designs. So comparing to the both the algorithms. So this is the variety of relay and antenna selection and of the pre-coding system. So this is also the SNR in the x-axis and YNR is y-axis that is a BER. So a variety of relay antennas, that is up to n number of relay antennas, and the precoding design up to 3. So there is a different number of precoding design. So this is one type of a precoding, and this is one, and this one, and this one. So these are the variety of relay antenna and selection of the precoding design. So in this next figure, the BER comparison of variety of transceiver design algorithms. So there are different types of transceiver design algorithms. So that is a SVD, single value decomposition, and then the sub-singular value decomposition, and then the sub-optimal joint iterative and optimal joint iterative. So these are the different types of algorithms using the design. So our proposed algorithm is SVD. So that is a single value decomposition. Compared to all the design, our SVD proposed is best, and then we calculate the x-axis in the SNR and y-axis in the BER. So it's a better rate and signal to noise ratio. Comparing to all the transceiver design algorithms, our SVD, that is a singular value decomposition algorithm, is best to compare to all the algorithms. So in this figure, the average MSE, that is a mean square error convergence of a class of transceiver design, that is calculated by the y-axis, that is the average MSE, and y number of iteration. So the three type of graphs, one is a green and blue and red. So number of iteration up to 10 iteration, we calculate the average MSE of the graph. So that is the convergence of a class transceiver design. So transceiver design means that is a SVD. So SVD means a single value of decomposition of the method. So overall, these are the running procedure of the product, and then the matrix of the dimension, it will be calculated by using bit error rate performance of the proposed SVD based relay and antenna selection technique, and transceiver design for a MIMO AF, that is amplify and forward two-way multi-relay system with making use of NRKIL, this 44834, and various spatial correlation between antennas. So under the optimal power allocation and correlated fading channels. So it is evident that when an increasing quality of rho is used, the effects of such correlation coefficient become very noticeable. Moreover, the bit error performance decreases dramatically when all the precoding design methods operate in high spatial correlation channel. Notably, the proposed SVD based technique as outperformance of the precoding approach is a fixed scalar of rho is chosen. So in this rho, we calculate the value of SVD based on the design technique. Provide the comparison of convergence, speed and steady state MSE performance between the proposed SVD based on the another precoding design methods in terms of the number of iterations of MIMO, so the multiple input and multiple output, A and F, that is the amplify and forward two. So now the proposed SVD based algorithms are available to provide the rapid adaptive convergence rates and the uniform better steady state MSE performance than those of optimal and suboptimal joint iterative schemes. So the note the sometimes comes near steady state after one of 3 iteration rounds as compared with the 6 and 9 iteration required by the optimal and suboptimal MMSE based joint design arrivals. So these are the overall running procedure for the product. Thank you for listening this video.